Welcome to Excel Data Analysis number 3. In this video, we get to study Power BI. In video number 1, we learned about the amazing standard pivot table. And in video number 2, we studied Power Pivot and a data model pivot table. And we'll use the same data set and create the same set of reports. But we'll get to create our data model using the Power BI user interface, including Power Query in the Data and Queries groups, how to create a date table with DAX measures, and then our amazing interactive reports over here in Power BI Desktop. Now, last video, we talked about the difference between a standard pivot table and a Power Pivot data model pivot table. But once you decide to jump over to Power Pivot, then you get to decide whether to use Power BI Desktop or Excel Power Pivot. Now, all of the advantages that we talked about last video for Power Pivot carry over to Power BI Desktop. Except, whereas you can share a Power Pivot data model over to Power BI Desktop, you cannot send a Power BI Desktop data model back to Power Pivot. And that's because Power BI has some DAX functions and some features that are not compatible backwards. And really, you don't have to decide between Power Pivot and Power BI because they work together. As we saw at the end of last video, you can just send your data model over. And because Power BI Desktop is a free download, might as well send it over there because the interactive visualizations are too good not to use that tool also. Now, Power BI has some amazing sharing abilities, but you have to have Power BI Online and a Pro license or higher. And of course, that costs money. Now, I was at an Excel MVP conference a few weeks ago, and some of the fellow Excel MVPs said that their customers were saying, forget paying for Power BI Online. Most people are using Power BI Desktop just like Excel. It's an app. You create your reports, your dashboards, and then you send the files to people. Now, don't get me wrong. Power BI Online is amazing, and we'll take a look. But that free download, all of you Excel people, it's just too good not to check it out. Now, one thing we saw last video and requires Power BI Online is you can store a single source of truth, whether it's the data model like we saw last video or the reports and dashboards. All of those things are in one location, and you can share them with your team. Another thing about Power BI is the engine works faster on big data. Whereas Power Pivot, behind the scenes, uses the MDX language, Power BI uses the DAX language. So if you really have big data, you probably do want to use Power BI. Also, Power BI allows us to create DAX tables and deliver them to the data model. And we'll see an example of that this video when we create our date table. All right, let's get started with Power BI Desktop. The first thing is, here are 2 links to download the free Power BI Desktop. The Microsoft download page, this one allows you to install it. And if you don't want to update, you don't have to. But when you want to update, you have to re-download it and install it. The Microsoft Windows Store, you download it, and it just automatically updates each month, like our Microsoft 365 Excel. Now, the data sets are going to be the same. We're going to have 2 dimension tables, and we'll have to point to this Excel file, and then we'll import the 2 tables. However, our fact table data are going to come to us in 3 different Excel files. Now, last video, we saw how to use a couple clicks to import and append text files. When you have Excel files, because there can be lots of different objects in Excel files, we have a different process. And it requires that we create a little M code inside of Power Query. But it's amazing. You can have all these Excel files, and later when we drop a new file in, all we have to do is click refresh. Now when you open a new Power BI desktop file, you see this window right here. I usually just X out, but this what's new is pretty good. Since Power BI desktop gets updated each month, you can go check that out. I'm going to X this out. And right away, I can see the file isn't named, so we use the keyboard, same as in Excel, for Save As F12. I'm going to give the file a name. The extension is .pbix. Click Save. Up at the top, we have our ribbon. Here's the Home tab, the Modeling tab. Over on the left, if you hover, that's the button you click to get to the reporting area. That's the area we're in now. Over here on the right, we can choose our different visualizations, and then we drag and drop fields and measures. We'll see our tables and fields here and filters here. The second button here is called Data. When I click, this is where we go to see our tables. We don't have any tables. This is also where we can create our measures attached to tables. Over here, this is called Model. When I click, this is similar to Diagram View and Power Pivot. It's where we go to look at our tables and relationships, even though we create most of our measures in Data View or in Report View. All right, our first step is we need to get the 2-dimension tables from our Excel file. So using Power Query in the Data group, I'm going to click the Excel button. Now you'll download this and unzip it. Inside, there's one file we'll use later. Inside of Start, the top 3 files, those are for the fact table, but this has the dimension table. So we're going to double click this to import one Excel workbook and then look inside of it to pull those 2 dimension tables. So I'll double click. This is the navigator window that opens up when you have files that have multiple objects. This is an Excel file, so we see objects like tables and worksheets. I want to check D product and D sales rep. By checking 2 objects, Power Query will create 2 import queries to bring these 2 tables into the data model. Now down here, we want to click Transform Data. When we click this, it opens the Power Query editor. This Power Query window looks almost exactly the same as the one in Excel. Over here on the left, we can see 2 queries. Right now, D sales rep is selected. That's the name. These are the steps. And we want to verify, just like last video, that we have the right data types. If we don't, you simply click and select the appropriate data type. So we're going to verify for both queries, name, steps, and data types. Now, different than Excel, whereas in Excel, when we close and load, we use close and load to, and then we have to decide which location we're going to use to load the data. In Power BI Desktop, we can only load it to the data model, or if we want, a connection only. We can right-click and uncheck this, and then it loads it as a connection only. But if we don't do that option, we can only load it to the data model. Now, the close means it'll close this window. The apply means it'll apply the query steps and load the data to the data model. And in the drop-down, you can apply steps, close, or both, and we want both. If we go over to Data View, we have a preview. This is D product, and in the field list, we can select a different table. This is D sales rep. Over in Model View, we can see our 2 tables. We'll get more tables here later and build relationships. Although in Power BI Desktop, it's really good at detecting the relationships and creating them automatically. Now what we did there was use this button to import multiple objects from one Excel file. Now our task is different. We have 3 Excel files, and we need to look into all 3 files and pick the objects that we want to append into a single fact table. Now, before we use From Folder to import multiple Excel files and append tables together, we need to go look inside of each one of these files. So I'm going to look inside of 2021. Power Query will have no problem importing this. It's a single worksheet with a proper data set. 2022, same thing here, proper data set on a single worksheet. But 2023, it'll have no problem with this, but Power Query will also try to import this sheet, and you could see we have some data, but lots of extra empty cells, and it'll bring all these empty cells in also. Not only that, but in the name box, we have a defined name it'll think that that's a separate object. And if you ever define a print area, that also will be interpreted as a separate object. Now in Power Query, it's easy to filter out objects like these that we don't want. So in this Excel file, we'll filter out everything except for this one proper data set. Also, the field names in all of the tables that we're going to append have to be the same field names. No extra spaces, no misspelled words. Now we can use From Folder. In the Data group, the Get Data button is similar to Excel. When I click the drop-down, I don't see From Folder here, so I come down to More. And in the Get Data dialog box, there's some categories here, but there it is, Folder. Now, when we use this option, last video we did text files, and everything's much more automatic when you use From Folder on text files. When you use From Folder on Excel files, then we're going to have different steps. But we click Connect. Just like last video, we have to give it a folder path. So I click Browse. I browse to the location. I'm telling Power Query to import everything from this file. And before I click this, let's go look and see what's inside. We only want these three. Uh-oh, there's a text file, and there's a .xlsm. Now, last video, we had a caveat. When we did From Folder, we said we're always going to make sure that we had the same file type. But in this video, we want to see Power Query has no problem. We can have different file types as long as there's some file type or file name characteristic that we can use to tell Power Query which files we want. And there is in this case. We want files that only have .xlsx. So there it is. I'm pointing Power Query, and it's got a lot of different files in there. I'm going to click OK. Click OK. This is similar to last video. There's the folder path. And we have a preview here in the extension column of the different file types. We want to click Transform Data. We can see our third query over here. Immediately, I'm going to come over and rename this fsales and Enter. Up in the formula bar, you can see folder.files. There's the folder path. As we know, if we need to edit this, we can change it here. Now, what we have here is a list of files and attributes. If you click off to the side, not on the yellow binary, but off to the side, you can see, sure enough, there's a preview or an icon of the file. Down here, we have a text file, and here we have an XML. Uh-oh, that one's open. Now, so we made this mistake. Let's go up to Close and Apply dropdown. I'm going to say Close the Power Query window. Now, this is different than Excel because we can come back to a query in Power BI Desktop that has not been loaded. Now, I went ahead and closed that Excel file. And in the Queries group, how we get back to the Power Query window is we go to the Transform Data dropdown and Transform Data. By the way, that's Data Source Settings. That's where you can go and change folder or file paths or settings for SQL databases and other data connections. But we want Transform Data. Now I want to come over to the query, fsales. I see it right there, but I can refresh. And now I have the 5 files in that folder. All right, we only want .xlsx, so we come up and we use our filtering skills from Excel. Click the drop-down. And when I have multiple items here, if I uncheck all and select .xlsx, now when I click OK, look at the Power Query M code function, table.selectRows. In the first argument of table.selectRows, it's acting on the previous step. For each row in that previous step, it looked at the extension field and said, are you equal to .xlsx? So that's how we can filter out and get only the file types that we want from a particular folder. There's a new applied step. Over here in the content column, do not click the Combine Files button. I don't know why they don't have this disabled for Excel files. It does not work. That works for text files. Now, before we learn how to get at each one of those Excel files, we don't need any of these attributes. So right-click Content, remove Other Columns. Now, the very first thing we have to do is we have to pull all of the objects out of each one of these files. And in fact, the 2023 file has more objects than we need. The other two have just one object, a sheet. And the way that we pull objects out of Excel files is we have to use the Excel.Workbook function. And we have to add a column. So we click on Add Column tab. And then we click on Custom Column. When we use Custom Column, it's like adding a helper column in Excel. All right, I'm going to call this New Column, Get Excel Objects. And down here, we have to type a function, Excel.Workbook. And watch this. I'm going to try and use the Tab key. IntelliSense does not work in Power Query, at least as of April 2021. It's broken in Power BI Desktop, and it's broken in Excel too. Now, we're using a Power Query function, and everything in Power Query is case sensitive. So if you don't get that capital E and the capital W and everything else lowercase correct, it won't work. Now, I open parentheses, and the screen tip shows us the first argument. Workbook is binary. Now, the word binary just means a file, and the content column contains a different Excel file in each row. So for the first argument, we can come over to Available Columns and double-click Content. That inserts it into the first argument of Excel.Workbook. Now, notice square brackets are used to refer to columns. Now, the screen tip shows us a second argument, so I'm going to type comma, use headers. Now, whereas in step 1, Excel.Workbook pulls all the objects, tables, worksheets, defined names. But once it pulls all those objects and we filter to show just the tables we want, step 2 for Excel.Workbook is to append the tables. And the use headers argument wants to know if we want to promote headers. So if we type lowercase true, what we're telling Excel.Workbook is once we get to the tables and append them, please only use the field names in the first row. And so that's our formula to pull all the Excel objects into Power Query. And once we get to the tables, to append them with field names in the first row. Now I click OK. And now we have our fourth applied step. Notice Table.AddColumn. It worked on each row in this table using Excel.Workbook. Now, if we click off to the side, not on the yellow word table, that's a table that lists the objects it found. Now, the data column has whatever the data is. The other columns are attributes for that object. The second Excel file has one object, but the third Excel file has multiple objects. And the kind column is one of the columns we can use to filter out and get just the objects we want. Now, this is a table listing all the objects, and each one of the Excel files has a table. I want to bring them all together so I can filter to get just the tables of data that I want. So I'm going to use the Expand button. And we want to uncheck this because I do not want this part of the resulting field names. I want just these. So I uncheck, click OK. Now I have yet another applied step. But more importantly, in the data column, I can click off to the side. There's one of the tables I want. That's a table, that's a table. But there's an object I don't want. This is that Excel worksheet with 3 columns of data and a bunch of empty cells. Here's the defined name, and here's that print area. So the first thing we can do to get at just the tables of data that we want is to filter the kind column and show only sheet. So I'll filter, uncheck, select just sheet, click OK. There's another step, and now I have only sheets. Now there's this one extra sheet here. So now the name and the item column are usually the same, so we can pick either one. And for each one of our file names, we're going to notice that they start with EDA. So we're going to filter, and we'll use a text filter. This is just like over in Excel. Begins with, and we'll click and type EDA. Now I click OK. There's yet another step. And finally, we filtered the objects to get just the 1, 2, 3 tables that we need to append. Now, I only want this column, so right-click, remove other columns. There's another step. Now, before we append, we'll remind ourselves that each one of these is a table with field names. So when we come up to the Expand button and click, you want to uncheck that. This is where the lowercase true comes into play. Excel.Workbook will append the 3 tables using these field names in the first row. When I click OK, bam, there's our appended table, one proper fact table data set. There's a new step. Our next step is to make sure that the data types are correct for all the columns. Now, all of these are going to have whole numbers, so I'm going to click on the first one, hold Shift, click on the last one, right-click, change type, whole number. Now, for date, we could use clicking the data type icon, date, but we want to consider the regional settings on our computer. My computer has month, day, year, so all I have to do is select date. But in case there's a discrepancy between the format of the dates in the data and the regional settings on your computer, you can use Using Locale. This dialog box lets you change the data type and select the locale of origin. So data type would be date. And for me, the regional settings are already English United States, and these dates are English United States. But if these dates were from France, I could use the locale option here to get my computer to understand that these are from France, but translate them into dates that my computer with English United States could understand. You would simply come down, select this option here, click OK, and bam, the French dates would be interpreted correctly on my computer. Now, I have both English, United States as a locale and in the column, so I don't need to do this, but that's an important step when dealing with dates. Let's click OK. It also adds a separate step. Change type was for all the other columns. This one was change type with locale. And now we have our appended single fact table. Now we can click Close and Apply. And we can watch it live here. It even put the relationships in. Now we have lots of measures to create in this fact table here. But our next task is to create a date table using DAX formulas. Let's click on Data or Table View. We can see we have 3 tables. Now, over here in Power BI Desktop, we have a new table button that allows us to create tables and add the tables to the data model. So I'm going to click New Table. All DAX formulas, whether you're creating a table, a calculated column, or a measure, have to be created in the formula bar. And we use the assignment operator, equal sign. I'm going to type the name of the table, ddate, equal sign, and we get to use the calendar function. Now we have to give calendar a start and end date, and it'll generate a table with one column of all the dates between the start and the end date. Now a date table must have a unique list of dates with all days for all years that are present in the fact table date field. If we do not meet this requirement, then the amazing date-related DAX functions and other date features will not work. Now we need to make the start date and end date dynamic, and they need to be pointing to the fact table. So when we add new data later, the date table can update. Now we're going to have to build a date using the date function. And actually, we're going to use date and year and min and max functions inside calendar. And all these functions are the same as over in Excel. All right, so for the start date, what's the year? Well, we're going to have to use the year function. And then inside of year, we use min. And I need to pick out from F sales date column the min date. So I close parentheses on that, close parentheses. And so now in the year argument of the date function, we'll always get the minimum year from the fact table, comma, month. Well, the beginning of the year is always January. comma, and the day is 1. So close parentheses on date. So that's a dynamic start date. And we're going to copy it. Come to the end, comma, and for end date, Control V. Then we just need to not find min, but the max. So in year, that'll always be the max year from the fact table. And what's the month? 12. What's the day? 31. And those can be hard-coded in because they don't change. All right, now we close parentheses. And when I hit Enter, we get a single column with all the dates. Even if we don't have sales on some of these days, they all have to be here for everything related to dates to work in the data model. Now, this is a DAX table. We didn't use Power Query to create this. And in the data model here and over in Power Pivot, they have data types. And I want to change it to date. I also want to change the formatting, although the formatting will not affect any of the calculations we make. I'm going to change it to MMDDYYY. Now, we also need to go over to Table Tools, and I need to mark this as a date table. So I'm going to mark as date table. The column with the dates will be date. And when I click OK, because we've marked it as a date table, our data model will be much more efficient. It disables the automatic date table creation mechanism, which creates invisible date tables behind the scenes when you use date columns. That's a feature built in for beginners, but it is not an efficient feature because you can have an excess buildup of hidden date tables. I'm going to click OK. Now let's come back to Column Tools. And actually, both in Table Tools, there's a New Column. And in Column Tools, there's a New Column button. I'm going to click New Column. This is going to be month number =, and we use the month function. And we can't select a column like we can in Power Pivot. We have to type it out, date. Now, when I close parentheses and hit Enter, the formula is automatically copied down the column. The DAX calculated column uses row context to get the date in each row and then create the month number. We're going to need that to sort the next column, which is month name. So new column. We'll call this month =. And if we were over in Excel, we'd use text, because that's the function that could take a date and format it as text. But over here in DAX, it's called format. It works exactly the same way. The value argument needs the date column, so we put the date column into the first argument of format, comma. And the custom number formatting is the same from over in Excel. You can put capital M or lowercase, it doesn't matter. That would give you the full month name, but I just want the 3-character month name. So that's it. In double quotes, close parentheses, and Enter. Now let's prove to ourselves that this will not sort correctly. I'm going to go over to Report View, and all I'm going to do is check month. And sure enough, it adds a table visualization. But there it is. It's not sorted correctly. So we come back over to Data, select this month column, come up to Sort by Column, and I'm going to say, please sort by 1 to 12. That way, January to December will be sorted correctly. So now that that column is sorted, we can come over here, and that is beautiful. Now we want one more column. We're going to call this year =, and year. DD, and the first column of the date table. Close parentheses and Enter. For the year column, we want to set some properties, because if I drag this into a table, for example, or other visualizations, the visualization will try to add these. So I'm going to say summarization. Please don't summarize. Now, you can add lots of other date attributes, from week number to fiscal year, fiscal quarter. But for us, the only attributes we're going to need in our report are year and month. All right, let's go back to Model. I'm going to close the properties, move the tables around. And now I can create a relationship by dragging date over to date. And it's smart enough to know that we have a unique list of all the dates. This is the one side. This is the many side. Now we created this date table by using the calendar function, and then we added individual DAX calculated columns using month format and year. Now I want to show you an alternative to adding individual columns one at a time. That means we can use all of these formulas in a single DAX table formula to create the date table. Now, I'm not going to actually show you how to type all the code out, but I am going to show you this just as a glimpse of what is possible. Now, I want to click on this DDate, Generate and Row Table. And there's the single DAX table formula that defines the entire date table. Now, the way this is created is I click the New Table button. I define the new table. We learned how to create variables last video. The first variable date column. That's the calendar DAX function we used earlier to create the single unique list of dates. And then generate is a magic function that takes two tables. That's the date column from there. And this is a one-row table with all of whatever our calculated columns are. And generate takes the two tables, and it does a cross join, bringing all of these calculated columns to every single row in the date column. Now you can see the first variable inside of generate actually has to use the date column, which is automatically generated by calendar. But all the remaining columns, including some fiscal period columns here, are created based on that one date column. These are all of the variables for all the calculated columns. Row brings them all together into a single row that's joined to the date column. And the beautiful thing about this is you can copy and paste this code. And the only thing you have to change for whatever fact table you have is the name of the fact table and whatever that date column is in both the min and the max. And then the full table is generated. All right, so you don't have to do this. The method that we used back over here, creating one column at a time, is fine. But if you want to try that, you can check this out in the finished downloadable file. So we've done step 1 in our data analysis process. We have used Power Query to import, clean, and transform the data. We have our tables. Then as part of step 2, the data modeling, the relationships were automatically created. Then using DAX formulas, we created a date table. And now, using DAX formulas, we need to create the measures. We can create measures either in data or table view or over in report view. We'll start in data view. You want to select the table where you want the measures to appear. Fsales already has some fields. We actually will hide these later and show just our measures. Now with the table selected, you can come up to Table Tools, Calculations, and select New Measure. Quick Measures opens up a wizard and steps you through a process to create the measures for you. We're not going to use that. We'll create our measures from scratch. You can also come over to the table and right-click, and right at the top is New Measure. When you do that, the default measure shows up, and there's what looks like a calculator icon. That's the icon over here in Power BI Desktop for measure. Remember, over in Excel, it was an f of x. Now, up in the formula bar, we're going to create our measure. And there's no measure grid like there is in Excel Power Pivot. We'll actually, when we want a preview, have to go over to Report and get a preview of the result there. Up in the formula bar, we'll type the name of our measure. And for total sales, we're not going to add a DAX calculated column and then sum. We're going to do the one-step method using the amazing iterator function SUMX. The table argument requires the table where you would have put the calculated column. So we put FS. I see F sales, so I hit Tab, comma. The expression argument is where we put our formula we would have put into the DAX calculated column. Now we need to calculate line sales. And line sales is the product price times the units for each row in the F sales table. Now we get to look up the product price from the dProduct table using the relationship and the related function. And the only field it needs is the column from the lookup or dimension table that contains the item we want to look up. So there it is, D price. Now related uses row context to see the product ID in each row to look up the correct price, times F sales units. And that's our formula. That expression will iterate down every single row in the F sales, calculate line sales, and then SUMX will add. Close parentheses and enter. Now we can see the formula in the formula bar. And over in F sales, there's our first measure. Now I'm going to create the rest of the measures over in report view. So I actually renamed this, double-clicked, and called this test measures. And we already dropped this in earlier when we were testing the month name sort order. And that was by default a table. So in Power BI Desktop, you can just click whatever the visual is. And when you click a different one, it converts it to that. So I'm going to click matrix. And a matrix is similar to a pivot table. And then it has rows, columns, and values area. Now, if I hover my cursor, this is fields. And this is very similar to our pivot table user interface. We drag whatever fields we want to the rows, columns, or values area. I see months in row. I want year, so I'm going to drag year above. And when I see my yellow line, I can drop. Over in the visual, I'm going to right-click, expand, entire level. We can resize this visual. And now with the visual selected, that's where we drag and drop fields. But look at this. We have a roller paintbrush. And when you click the paint roller, it exposes expandable categories for all the different types of formatting we can apply to the visual. For example, we could select grid. And if we scroll down, there's text size. I can increase this to 12. Coming back over to fields, we'll use this visual, and we'll just test each measure as we create it. Making sure that the visual is selected, I can check total sales. And it looks like it's working. Similar to a data model pivot table, here we have a matrix showing us the year and month totals from our SUMX measure. Now notice that the totals are at the top. And that's an element that we can format in this visual. So we go over to the paint roller. And when you're coming from Excel, it takes a while to figure out where things are. But this one is subtotals, so I'm going to check that. And down below, there's row subtotal position. I'm going to say at the bottom. And now it's at the bottom. Now we'll use this visual to test our measures as we create them. Now we can come over to F sales, right-click, new measure. Our next measure is total units. And we can simply sum on the existing F sales units column. Close parentheses and enter. I can see the new measure over here. Selecting the visual, I'm going to check the measure. And it looks like I need to add number formatting. And look at this. We did total sales over here on SUMX. And it had a default number formatting, but this one did not. Clicking on total units. I'm going to apply comma, make sure that 0 is showing, and that's much better. Let's go back and select total sales measure. And instead of leaving it general, I'll click comma, making sure that there are 2 decimals showing. Now right-click, new measure. The next measure is going to be number transactions. And as we learned about last video, there's an amazing DAX function called COUNTROWS. And because the fact table is in the center surrounded by dimension tables, and all the filters flow from the dimension tables to the fact table, all we have to do to count the number of transactions for any conditions or criteria we drop into the visuals is use COUNTROWS on F sales. Because whatever filter there is will filter the fact table, and COUNTROWS will count how many rows there are. So that's number of transactions, and enter. I'm going to add comma. And this formula is counting, so 0 decimals is perfect. Now I can check number of transactions. And everything is looking good. Now our next measure is going to be average monthly sales. And that requires we add a new column to the date table. So I'm going to go back over to data view or table view. Select date table, new column. We'll call this end of month. And we'll use the end of the month function. We need to look at the date column in the date table, comma, and we need the end of the current month for each row. So we put a 0. Close parentheses and enter. We'll add some number formatting. And as we learned about last video, the importance of this column is that we use it in the first argument of AVERAGEX to get the total sales for each month and then average those numbers. And we can't use the month column with text January, because then January for 2021 and 2022 and so on, all of those Januaries would be treated the same. So you would get a total that's too big. Whereas if we have end of the month for each month, then we have a unique identifier for each month, regardless of what year it's in. Now to create our measure, we're going to go back to Report View. Make sure that F Sales is selected. New measure, average monthly sales equals, and we'll use AVERAGEX. And the first argument, table in AVERAGEX, allows us to put whatever table with whatever grain or size we would like. And so we want to use values, which picks out a unique list in the current filter context for whatever visualization we're using on the D date end of month, close parentheses. So values is delivering a table. For example, down here, here's 2023. In this row right here, the date table is showing only 2023 days, but the values function picks out a unique list of the 12 months for that year. In the total row, the values function will deliver 12 months for every year for a total of 36 rows. And now when we comma and get to expression and put the total sales measure, now wherever this formula is in the visualization, the total sales will iterate across values, get the pre-aggregated total sales, and then AVERAGEX will average. Close parentheses and enter. I'll add some comma, number formatting, make sure it's 2 decimals. Make sure the visualization is selected. Check average monthly sales. Now, the monthly sales are going to be exactly equal to total month sales because it's averaging a single number. But down here in the year rows, the formula is working. Later, we'll use this particular measure in the product by year report. The next measure we want is year-over-year % change for total sales. So for example, in the March row in the visualization, we somehow in the DAX formula need to access total sales for March of this year, but also total sales for March from the previous year. That means inside our formula, when the filter context for March 2022 flows in, we need to push it back 1 year. And the way we change the filter context in DAX is to use the calculate function. We also get to use the amazing time intelligence function, same period last year. We'll right-click F Sales, New Measure. We'll call this year-over-year sales % change. And we're going to need to calculate the previous period sales 2 different times. So when we have a formula element repeating like this, we can create a variable. Shift-Enter, VAR. That means we're about to define a variable, space. And we'll call this previous period. And it will be equal to, well, we need to change the filter context, so we use calculate. And in the expression argument, we want to take total sales. And with no filter, it calculates the current period, comma. But when we use a filter in the amazing same period last year, with, in the dates argument, the date column in the date table. And this is one of those time intelligence functions that works perfectly with the date table to take whatever the filter context flowing in is and throwing it back a year. Same period last year delivers a valid list of dates. Calculate takes it, throws it into total sales. The fact table is filtered to the last year's period. And bam, we get total sales for the previous period. Now Shift-Enter, and we want to use return. Everything after return is going to be our formula. But check this out. Shift-Enter. Let's just see. And we'll down arrow down to the XY variable, tab. And we'll just enter this and see if it actually is giving us the previous period sales. So enter. I'm going to select the visual, check our measure, collapse the formula bar, select F Sales. And sure enough, for January, it got the previous period sales. Now, one thing we're going to have to do is these are all the correct previous periods by month, by year, But in the grand total cell, that number is meaningless, and we don't want our calculation there. So to show a blank in the grand total cell, rather than the formula, we want to notice that everywhere in the report, the year column in the date table shows exactly 1 year. 2023 and all of these months, there's just 1 year. 2022, just 1 year. It's only the grand total cell where the date table is showing more than 1 year. So we'll create a logical test using the HASONEVALUE DAX function on the DDate year column. Now let's click back on our measure. And below return, I'm going to tab if HASONEVALUE, there's the year. So the logical test is asking, does the filter context have 1 year? Comma. When it's true, we want to divide in the numerator the difference between total sales and total sales for whatever the previous period is, comma, and then we compare it to our variable previous period sales. Now we're going to leave the third argument of divide out. That way, if it gets a divide by 0 error, it'll show blank. And same thing for if we leave it empty and the logical test is false, it'll show nothing with that blank function. Close parentheses, and that's our formula. Actually, we could format this, Shift-Enter, and then before divide, Shift-Enter, backspace, Shift-Enter, backspace, and we'll close off on the if. I'm an Excel array formula guy, so I always type my formulas out linearly, but this is the convention for DAX. When I hit Enter, add some percentage number format, click on F sales to collapse that formula bar. And there for 2022, we can see the monthly year-over-year percent changes. In March, we get correctly 16.19% change. In the total row, we get 20.19%. And if we scroll down, all these percentages are working, and the grand total is showing nothing. Now look at this. The font sizes are different. Those are different formatted elements. So we come over to our paint roller. On the grid, let's say text size back down to 10. And then subtotals will match that. All right, so our calculation is working here. Now what we want to do is we want to compare each individual monthly sales amount to the yearly total. So we get percent of year total. We're also going to see how to compare all of the values to the grand overall total. And the way we calculate the grand overall total in every single cell is to remove all filters from the entire data model. And you do that with the ALL DAX function. When we want to remove everything but the year filter, then we use the DAX function ALLEXCEPT. We'll create our measure up in the formula bar. Percent of grand total is the name. And we're going to divide. And in the numerator, square bracket T, there's our total sales. So it'll see the filter context in every single cell, comma. And in the denominator, well, we need the grand overall total. And anytime you're changing the filter context, you use the calculate function. Just type the letter C. It's the first function at the top, and tab. We want to change the filter context for total sales measure, comma. And in the filter argument, this is where we use all. Tab. And the all function can take a table or a column, and it removes all filters. Now, we're going to put the fact table F sales into all. In a star schema data model, the fact table is in the center, surrounded by dimension tables. All filters flow to the fact table. So when we remove all filters from the fact table, it removes all filters in the entire data model. So it doesn't matter what conditions we drop into our visualization. This is going to take all the filters away, close parentheses, and calculate will change the filter context so that that total sales calculation has every row in the fact table. Now we're going to close parentheses on calculate and on divide. Enter, add percent number formatting. Make sure your visual is selected, and check percent of grand total. And every single sales amount is being compared as a percent of the grand total. Now let's come up to the formula bar And I'm going to copy this, Control C, Escape. Make sure that the fact table is selected, New Measure, Control V, and instead of % of grand total, I'll say % of year sales total. And we need to change all to all except. So with my cursor after the L, I type in E, there's all except. And I have to click back inside because all except has a table, and then I comma. I want the column that should still filter the fact table. D date year column. So all filters are blocked except for that year column. When I hit Enter, add some % number formatting. Make sure the visual is selected. Check my measure. And bam, there it is, % of year total. All the way down. Now the grand total cell shows 100%. Maybe you want that there, maybe you don't. We can amend it. And I added if has one value on the date and added some formatting. And now when I hit Enter, the grand total cell does not show a value. I'm going to click on % of grand total. And I'm going to change this to indicate that the measure that we're using is the sales measure. And Enter. Now we've created our 7 measures. And we created them in the reporting area on a page called Test Measure. If we look over at our F sales table, we can count 7 little calculator icons. But there's a bunch of fields, and we want to hide these fields. So we'll go over to Model View. And as we talked about last video, we don't want to leave a number field in a fact table because we don't want anyone to accidentally drag and drop it into a visual, because then it creates an implicit measure. We also don't want them to drag date from the fact table. We want them to drag date and any attributes from the date table. So I click on the first one, hold Shift, click on the last one. And over here in Power BI Desktop, when we right-click, it's Hide in Report View. End of the month was for a calculation. Number of months was for the Sort By action. We want to hide, so right-click, Hide in Report View. Cost and price, those are for calculations only. We don't want to drag and drop. Holding Control, click on Product ID. We want to hide that too, so right-click, Hide in Report View. Sales Rep ID also. All right, so we're done with our data modeling. We use Power Query to bring all the tables in. We use DAX formulas to create our date table and a bunch of measures. We created our amazing relationships that allow filter context to occur, allow us to drag and drop fields from any table into any report, and of course do formulas like with our related function. And now we've hidden the fields we don't want in reporting view. So now in Power BI Desktop, we're ready for Step 3, Reports, and Step 4, Visualizations, all at the same time. So we go over to Report View. Now in the reporting area, these are called pages. We'll add a new page in just a second. These are the tables with the different fields. And notice now our fact table has only measures, and the date table shows 3 fields. And the visualizations have both report-like visualizations like a matrix or a chart-like visualization like a line chart. And there are lots more visualizations, including this More button where you can get things like word clouds. And then we have the filter area, which is sort of like the filter area in a pivot table, but it has a lot more versatility. Now let's see how to do this. We'll come down and click the New Page plus symbol. Double-click this, and we'll name it. Enter something like Year Month Sales Report. All right, I want to make sure that the white area is selected. And our first report will be a matrix, so I'm going to click Matrix. From D date, I want year in the row, month below. I'm going to see my yellow bar. There it is. And I can simply check total sales. Over in the row area of the visualization, I'll right-click, expand entire level. We can resize. Now, with this matrix selected, I'm going to copy it, click in the white, Control V, and drag it out here. And I can convert this matrix to a line chart by simply selecting it and then clicking Line Chart. Now watch this. When I resize this, it comes out more perfect than a line chart in Excel by a long shot. There's a chart title, which shows the measure and the conditions filtering that measure. The measure name is in the vertical axis. Down here, we see our conditions and criteria in the horizontal axis. Any visualization that is selected, we have our field area, which is where we dragged and dropped, or we copied and pasted. But there's our format paint roller. So I'm going to click. And for the horizontal or x-axis, I'm going to look through here, and there it is. I'll click this drop down, and we can look through and format. And sure enough, look at this, concatenate labels. If I turn this off, that looks much better. So literally 1 or 2 clicks, and I have a chart that is looking amazing. Now there's more amazing things to Power BI visualizations. If I hover over a data point, that's called a tooltip. Now we have these over in Excel pivot table or chart. But what's cool about a Power BI visualization is we can come over to Fields, and down under Tooltips, we're allowed to drag measures here. And then when we hover, the result for those measures will show up in the tooltip. Now this chart is showing sales. So I'm going to drag year over year change down to tooltips. And then this percent of year sales down to tooltips. And just like that, they show up in the tooltip. For any given data point, all 3 measures are being calculated. Now this is kind of wonky. Whatever measures we drop into the tooltip are going to show up in the chart title. And I think I just want total sales by year and month, that original label. So we can go over to the Format Painter and down to Title. And I can't find a setting that says turn off the tooltips, but we can edit this. And it's kind of hard to edit down here, but I'm using my arrow keys and then Shift and arrow. I've highlighted what I want to delete and enter. And I like that more concise chart title. So we have our field list to drag and drop. We can choose our visualizations. Field is where you drag and drop. The paint roller is where you format. We also have filters. And for the conditions that we dragged and dropped in the field area, they show up as fields on this visual. And you can come over and filter it, clicking the drop down. You could do something like is less than 2023 and click Apply Filter. If you want to get rid of it, you can click the eraser. I'll collapse that. Now, we have filters over in a standard pivot table and a data model pivot table. And if we were to drag a field here, we could filter this page, which is sort of like a pivot table. But we could also drag some filter here for all of the pages. So the 3 sections of the filter pane allow us to filter just the visualization, this whole page, or all the pages. That's a pretty powerful ability to filter. Now, the next amazing thing about these visualizations is if I click in the matrix 2022, the matrix and the chart are both filtered. That's the interactive part of Power BI that's missing over in Excel. If I click 2022 again, now I see all the years. Now, you may or may not want that, but we totally have the ability to select whatever visualization it is, and then go up to Format and edit the interactions. So when I click Edit the Interactions, because this visual is selected, now I have the ability over here. If I say Don't Filter, now when I click 2022, it's not being filtered. I think I like the ability to be filtered. Now if I select this visualization and I have that on, now I can see up here, and I think I don't want this one to be filtered. So now if I click a data point, it's not going to change this. Click it again to turn off the filter here, still not changed. So that's a great way to control the interaction between visualizations. All right, now up at the top, there's some controls here, and they do some pretty amazing things. If you click the ... you can actually export the data as a CSV file. You can show as a table, and when I click, it has a table, and you can switch it side by side or vertically. Then you can click Back to Report. There's also Spotlight, which grays everything out except for this visualization. And you can do sorting. We can point to Focus Mode, makes it bigger, Back to Report. If you have any filters from here, when you hover, it shows you what the filters are. The next 4 arrows are for drilling down, drilling up, and going to the next level. Right now, we have 2 variables. So if I click the drill up, it'll show me the totals for year. From the year variable, I have 2 options. I can go down to the next level, which shows me the total of all the months together. So when I click, that's all the Januaries together and all the Februaries. Drilling back up. When I click this option, I go down 1 level and see both variables. Now if I drill back up, if I don't have this option on, when I click on 2022, it just filters other visualizations. Click again. But now if I have drill down on, now when I click on 2022, it shows me the months, which is the next level for 2022. Back up. I can look at 2021. Back up. Down to the next level, showing both variables. Now we have data for 3 years here. Later we'll get new data and we'll have a 4th year. Now this is a line chart visualization. And the line chart is the perfect visual when you want to show changes or trends over time. Now we're finished with this page. We want to go and create a new page with some new visuals. I already clicked the plus button and named it Year Metrics Dashboard. Now here's the dashboard we're going to create. A matrix, a clustered column, a stacked bar, a clustered bar, all to monitor yearly sales. Now wait a second. Did I use the word dashboard? I even had the nerve to name this page in this Power BI report a dashboard. I say that sort of as a joke, but over here in Power BI Online, the word dashboard has a very specific meaning. For a given workspace, there can be dashboards. And this is a dashboard that has visuals pinned from multiple different reports and even an Excel workbook. So technically, in Power BI, when we use the word dashboard, we're referring to this location. But a dashboard built to monitor activity can be built anywhere. We can build it on an Excel sheet. We can build it on a page in a Power BI report, because a dashboard like this can be defined as one location where we can present useful information and metrics for decision making. That information is presented in a neat and organized manner. We can have tables, charts, visualizations, data validation pictures, and whatever else you want. And very importantly, when new data arrives, the dashboard can be refreshed. We all know what a dashboard is. If you've ever been in a car, that dashboard in the car is helping you to make good decisions. To start the year metrics dashboard, we want to click inside the white, come over and click Matrix. From the D sales rep, I'm going to check region. That sends it to the rows. I want year, but if I check it, it'll send it to the columns. So usually I just drag it, and I want it below region. Then I want to check total sales, year-over-year change. In the region, right-click, expand all. And now we have a region by year report. Now, although this is a matrix visual, this is in a table format. And table formats are good because they show all the detail. But if you want to take the same categories and amounts and have a more immediate visual impact, we can choose a different visualization. And the best visual to compare amounts across categories is either a column chart or a bar chart. And there are 2 types for each. There's a stacked bar or a clustered bar. Stacked column or a clustered column. We'll choose clustered column. Let's start off by checking region and total sales. Now, when you have one variable like region, then clustered and stacked are exactly the same. It's when you have 2 variables for some amount that there's a difference between the stacked and clustered. Now I want to drag region to the legend, year to the axis. Now we have two variables, and we can see that the columns from the legend are clustered together side by side. When you use a clustered column or bar, the emphasis is on comparing whatever amounts are in the legend. Clearly, we can see Washington is bigger for 2021, but California is bigger for 2022. Now, when we switch over to stacked, it means it'll take whatever items are in the legend and stack them on top of each other. So if I select stacked column, the same two variables are there, and the same amount is there. But here, the emphasis is not on comparing the legend, but we want to be able to more clearly compare whatever the variable is in the horizontal axis. So we can clearly see that 2023 is the biggest year. But we still have the detail from the legend. Now let's select cluster. And I'm going to come over and drag year over year change to the tooltip. And notice the first year doesn't have that metric, but it's smart enough to know the amount of change from California from the previous year was 36%. All right, so we can resize and move it around, and we can see the red lines that help us line everything up. Actually, it's sometimes hard to grab over here in Power BI. In Excel, we get a different cursor, but over here it looks the same. And there we go. We can try and center it. All right, our next visual is total sales by product and year. So I'm going to click in the white, and I want a stacked bar. Product is going to go in the axis, year into the legend, check total sales, drag year over year sales down to tooltip, percent of year down to tooltips. I can see it emerging over here. We can resize it, click and drag. Come over to Format, Title. I'll adjust this. That's looking better. And I forgot over here, I'll click on the visualization and format the title in the same way. All right, so that one's looking good. Now we want to do our fourth visual. Make sure the white is selected because, and this is something I do a lot, if I leave this selected and come over and select clustered bar, oops, it converts it. Control Z. So make sure the white is selected. Clustered bar. I want the supplier for the products in the legend, year in the axis. And the metric I want is average monthly sales. And it looks like it came out perfect, including lining up with a visual above. I'd like to see Excel do that. Now this is an insert after I finish the video because I left out one teeny detail. If you want a visual like this, but you still want to see some of the detail, select the visualization, come over to our paint roller, and just like in Excel, there's data labels. I can turn them on, and boom, right at the top, you have data labels. And that's looking good. Now let's decide how these visualizations can interact. If I go up to Format, and in fact, before we click that, let's see what the default is for these bar and columns. If I select Washington, that's a different default than we saw on the line chart. And if we select the matrix, click Interactions, we can see there's three options. I don't want any filtering, and that's the highlighting. So for this matrix, I don't want this to be filtered at all. This one will leave the default highlight, and this one I want to be filtered. So if I turn this off, and now when I click Washington, this one's filtered to show Washington, and this one highlights Washington. Where for that full bar there, that's just the Washington part. And down here, that didn't get filtered or highlighted at all. Clicking back on Washington. All right, so we're done for this dashboard. Now I went ahead and added the last page, called it Product Metrics. I created a matrix with product year and these measures, and then a line chart with year in the axis, product in the legend, and average monthly sales. Now we have 1, 2, 3 different pages and a sheet with test measures. Now at this point, you can save and share the file just like an Excel file. But we want to see how to publish and bring this to Power BI Online. Now, before we do that, when we publish, these will show up as pages. This will be a report that we can click on and then view the different pages. But this was just for testing, and we want to keep it here, but we don't want to see it online, so we can hide it. Right-click, Hide Page. Now we want to publish to PowerBI.com. And to get the most out of the online Power BI, you need the Pro license or higher. But I'm going to click Publish. It wants to know which workspace. And a workspace is a great area where you grant access to people, and they have access to the reports, the data sets, the dashboards, and more. So I'm going to use this established workspace, and then click Select. It's publishing. Now I can jump to Power BI by clicking this. If you're logged in to Outlook or any other Microsoft 365 app, you can use the App tile, click Power BI, or you can simply type powerbi.com and enter. You need to sign in. Here at Power BI Online, we have our workspaces listed at the top. Over on the left, we can choose a workspace. This is where we save the report. And there's our report, and there's the data set. Now, both the report and the data set are available to people who have access to this workspace. So clicking Access, you add the emails, and then those people would have access to everything in this workspace. To view the report, we simply click. Over on the left are the pages. Clicking on each page. The page works the same as in Power BI Desktop. When I select a particular element, it does what we programmed it to do over in Power BI Desktop. You can also share up in the Share dropdown. If you click Report, you can enter email addresses and email. Down here is the report link that you can copy and send to someone. Also, if you want to publish it at a website, for example, you could get the embed code here. And one of the benefits of Power BI Online is when you share the report, they can view it on any device, their phone, a Mac, their PC laptop. Now, when you get the correct license, you can build new workspaces. It's as easy as create a workspace, and then you add people's emails. Then you can share your data sets and reports. Also, if we go back to the workspace, that's the report, but here's the data set that was uploaded. If I click this, if I wanted to, I could create a report from scratch here, and it's very similar to Power BI Desktop. You could also bring it over into Excel and create a pivot table. Now, last video we saw that if I go back to this workspace, any of these data sets here, whoever has access to this, in their pivot table dropdown, they can build pivot tables based on these data sets. The last thing is a dashboard. So if I come over to the workspace and click the dropdown, there's no dashboard. But you can pin any visualizations from the different reports and even an Excel workbook to a dashboard. So if we went to this report, let's go over to Year Metrics. If I want to share this, and we don't have any dashboard, so when we share it, it'll ask us to create one. Up under More Options, I can say Pin to Dashboard. I'm going to call this EDA as the dashboard name and Pin Live. If I go back over to our workspace, here's a different report. I'm going to come up, Pin to Dashboard. I definitely want it on that dashboard, Pin Live. And now we have a dashboard over here. And when I click Refresh, then over here, clicking on our dashboard, this is pinned from one report. This is pinned from a different report. And you have your sharing options up here. All right, so that's just a tiny look at Power BI Online for sharing. Back over here in Power BI Desktop, here's the moment of truth. There's our new data in an Excel file. Copy, paste. In Power BI Desktop, in the Queries group, we click Refresh. There's 4 years here, even in the legend and in this bar chart. If we look at our query, clicking Transform Data, selecting F Sales, selecting Added Custom Column Step. What? I don't see the 4 tables? Refresh. And there's all 4 tables. Now we come over and click Publish. It wants us to save. And select a workspace. Click Select. Should we replace it? Yes. Over here in Power BI Online, we can refresh with F5. And bam, everything's updated. All right, in this video, we did a lot with Power BI Desktop. We started it off with Power Query. We imported 2 Excel tables, but very importantly, we saw how to go from a folder and use the Excel.Workbook function to import tables from multiple Excel files. We saw how to create a DAX date table. We even saw a glimpse of this DAX date table. Then we created all these different DAX measures, all in report view, so we could see the formulas evolve. Then we saw how to do these amazing visualizations, including things like adding tooltips and how to get visualizations to interact in different ways. And then, of course, we saw how to publish to Power BI Online so people can view your awesome reports and dashboards on any device. All right, if you like that video, be sure to click that thumbs up, leave a comment, and subscribe, because there's always lots more videos to come from Excel is Fun, including next video where we deal with big data, and we'll see how to do it both in Power Pivot and Power BI Desktop.